Now I discuss a third problem when I want to show the relationship between linear demand curve and uniform distribution. After showing that, I will go from uniform distribution to binomial distribution, because as soon as I set a price, I can show that the problem is transformed into a binomial distribution. In binomial distribution, I can easily compute average and standard deviation, and that would be average and standard deviation of daily demand. Then if I am going to compute average and standard deviation over several days, which in this case is 2.5 day production and 1 day shipment until I get the product, then if I am going to add 3.5 binomial random variables according to the central limit theorem, that binomial random variable can be assumed as a normal random variable. Now I have the normal random variable, I have its average and standard deviation. Then I can compute how much do I need in order to make sure that with a certain probability I can satisfy the demand. I will go through all these steps one by one. Here is our linear demand curve. We have already computed it, and we know that price is equal to 175 minus 2.5 Q. We want to connect it with the uniform distribution. If I set the price equal to 0, probability of sales is 100%. So if this is price of 0, probability of sales is 100%. So it is to the right, and this is 175. And this height is height of the uniform distribution. But if I set the price equal to 175, probability is 0. Therefore, I should not look at this side. I should look at the other side, because it is in this side when the probability is equal to 0. And it is in this side when the probability is equal to 1. So if I set any price, for example, this price, probability of sales is computed like this. Given that demand curve, if I set price equal to 0, I can solve this equation and I get Q equal to 70. So the maximum I can solve, even at price of 0, is 70 units. Therefore, I can assume that I have a uniform distribution between 0 and 175. If I set the price equal to anything, probability of sales is this right-hand side. Why it is this? Because if I set the price equal to 0, probability is 100%. So it's not this side, but it is this side. And if I set price equal to 175, probability is 0. Therefore, it is not this side, but this side. So given any price, probability of sales is computed as this area. For this area, I have the width. All I need is to find the height. The minimum value is 0, the maximum value 175. Height of it is referred to as f of x. Area is computed as width multiplied by height equal to 1. This is width 0 to 175 multiplied by height, which is h, is this area, and probability of all possibilities is always equal to 1. Having said that, I can simply compute h as 1 over 175. And the random variable x, has its f of x equal to 1 over 175. 0, 175, 1 over 175, and this, if this is the price, the probability of sales is this. This is x, 175 minus x multiplied by 1 over 175. This is the distribution defined between 0 and 175. Compute the probability of sales if the price is set equal to 20. So this is the probability distribution, and this point is 20. And this height is 1 over 175. And this point is 0. Therefore, that probability is equal to this side of the curve, or 1 minus this side of the curve. Both of them are correct. That is 175 minus 20 multiplied by this height. Or it is 175 divided by 175 minus 20 divided by 175. In other words, we can consider this also like this. This is 20. This is 0. So this width is 20. This height is 1 over, it is this probability here. But we are looking for the blue probability, which is 1 minus 20 divided by 175. And that is what I have it here. Both of them are the same, and probability of x greater than 20, which is our price, is about 88%, 89%. Compute the probability of sales if the price is set equal to 145. This is 145. Probability of sales is to the right, and therefore it is 1 minus probability of the left side. 1 minus probability of the left side is 145 multiplied by 1 over 175, which is, this is the probability to the right. This is probability to the left. 1 minus it is probability to the right, which is 0.17, 0.171. So if I give you a linear demand curve like this, you should be able to associate it with a uniform distribution like this. And because this height is 1 over 175, then you should be able to compute all these probabilities. Compute the probability of sales if price is equal to 105. Again, 0, 175. Price is 105. Probability of sales is to the right. Because if I set price equal to 175, probability of sales is 0. And if I set price equal to 0, probability of sales is equal to 1. Having said that, if I set the price equal to 105, probability of sales is this. And that is simply 1 minus 105 divided by 175, which is 0.4. The probability is 1 minus this side, when this height is 1 over 175. The red area is computed as 105 minus 0, which is 105, multiplied by 1 divided by 175, which is 175. This is the red area, but we are not looking for the red area. We are looking for green area, which is 1 minus the red area. And that is 0.4. Given that price, compute the expected average revenue from each individual visitor. We have set the price equal to 105. Probability of sales is 40%. This is a very neat idea. Now, anyone who comes to this website, the probability of sales is 40%. So P is equal to 0.4. How many people come to this website per day? As we computed earlier, 70. Therefore, N is equal to 70. So we have a binomial distribution where the probability of purchasing our product is 40% and 70 people per day visit this website. From demand curve, from linear demand curve, we went to uniform distribution. Now, from uniform distribution, we migrate to binomial distribution. From a continuous probability distribution, now we migrate to a discrete probability distribution. If P is 0.4 and N is 70, daily sales is N times P, which is 70 times 0.4, which is 28. Every day, on average, we sell 28 units. Variance of this distribution is NP, which is the average, multiplied by 1 minus P. NP multiplied by 1 minus P. That is 70 times 0.4 times 0.6. That is variance of sales. We sell the product for 105. A person who comes with probability of 40% buys it. If the visitor was buying our product with 100% probability, we would have collected $105. But there is only 40% probability that he buys it or she buys it. Therefore, 0.4 times 105 is equal to 42. From each visitor, we collect $42. How many visitors? 70 times 42 is our total revenue per day. We could have looked at the same problem from another angle. How many people visit us? 70. What is the probability of purchase? 0.4. Therefore, out of all customers, out of 70 customers, only 28 of them purchase our product. How much do they pay for this product? Very interesting, 105. If you multiply these two numbers by each other, it is equal to these two numbers. So we may assume that 70 people come to our website. So the number of people who buy it is 0.4 times 70, but they each pay 105. At the same time, we may assume that customer come to our website with probability of 40% will buy it. Therefore, from each customer, we only collect 0.4 times 105. But how many of them are there? 70. Think about it a little bit. Very neat idea. Sale price and 105. Probability of purchase is 40%. Therefore, from each customer, we collect $42. Given the linear demand curve, compute the maximum daily demand, total number of visitors per day. That is quite simple. We have already computed it. We set this equal to 0 and solve the problem. And we compute 70 customers. We have done it before. Now, given the price of $105 and the maximum number of visitors per day, which is 70, How many units do we sell per day? Very simple. Probability of sales 40%. Number of visitors 70. Expected number of units sold 0.4 times 70 equal to 28. Given the above price of $105, compute the average total revenue. We can do it in two ways. We may assume, as I explained it before, we have 70 visitors, probability of sales is 40%. If I multiply 40% by 70, expected number of units sold is 28, and each one is sold at $105. The total revenue is this. We can compute the same number in a different way. So one way is to multiply 28 by 105. The other way is 40% is probability of sales. Each unit is sold for $105. Therefore, on average, we get $42 from each customer. And then we write sale price, 105, multiply by 0.4 is equal to 42. But here, 70 people visit our website, 2940. We can multiply 0.4 by the number of customers, then multiply the result by actual price, or we can multiply the price by the probability and then multiply it by actual number of visitors. Both will give us the total revenue. Given the above price, compute the standard deviation of the number of units sold. For uniform distribution, we have these formulas for average and variance. For binomial distribution, this one. But now we are talking binomial distribution. We have a probability of sales, and then we have number of visitors. Therefore, we can easily compute NP, and we can compute NP times 1 minus P, and those are here. So each day, on average, we sell this many units, and the variance is this much. Standard deviation is the square root of that number. So now, because we have a lot of random variables per day, and we compute the average and the standard deviation of them, we can use this average and standard deviation for normal distribution. We can assume we have a normal distribution with an average of 28 and a standard deviation of 4.1. That is our daily demand. Under price of 105 and under 70 visitors per day. These are very neat ideas that your professor in statistics definitely has explained it to you. But now we are trying to have a second look at them and also, more importantly, try to link these things. Thank you very much. And now I can start problem 4.